So I think we have quite a bit of time for discussion.
I was thinking about this, is it a separate program, this, where they have their group discussions and work together? So with GeoGebra inside it, so to say.
Right. It is. It's called Virtual Math Teams.
Yeah. It's a free.
Yes. Yeah, so the whole thing, including the chat, is the Virtual Math Teams.
Yeah.
And this has different tabs in it. This is open to this tab. This is the GeoGebra multi-user version of GeoGebra.
Okay.
Within the Virtual Math Teams environment.
So as a teacher, you put a team of students together and,
yes.
and give them the availability to this.
Yes.
Room. Okay.
Yeah. That's exactly what you would do. You'd set up a room with the curriculum that you want them to see and the workspace for them. And then you'd put, say, 3 to 5 students in each room, and they would chat about what they were doing and do their GeoGebra work together. And they would take turns doing the GeoGebra.
Well, it's a good idea. I haven't seen this. Very nice.
Do you think you can show the chat room that you and I and Christian worked with this morning?
Oh, you read
Just
that.
to give it, just to give them some like feeling was about it.
So over here I've gone to vmt.mathforum.org/VMT lobby. So anybody can go there on the web.
Okay.
And you come to this, what we call the lobby of the VMT project. And this allows you to find a chat room. Like if you're a student, then you'd go here, you'd log in, and you'd come to this lobby. And here we have, then you'd find your project, which so here we have a project, Gothenburg. So if you were a student in Thomas's course, you would go, well, your login would be automatically probably associated with Gothenburg in the first place, so you would automatically go there. If not, you would pick that and say apply filter to just get the chat rooms for your project. And then we created 3 rooms here within the Gothenburg project under the subject of geometry. And the topic is getting started with GeoGebra. And so if you had 3 groups of students, you would say, you 3 students go to room 1, and you 3 go to room 2, and you go to room 3. And the students who were assigned to room 1 would click on Thomas number 1, and it would open up the room. Oh, here's the room.
Okay.
It's a little too big. Okay. So here's the room, and Thomas had set it up to just have this welcoming message in it. And then the students who were in here started chatting with each other and constructing the triangle and so on. And you have the full power of GeoGebra in here. You have all the regular tools. If you take control, then the tools become active, and you can create new objects. And drag them around.
Yeah, yeah. And the students can help each other with that.
Right, and then I would release control, and somebody else would take control, and I would say
Okay.
in the chat, I'm done. Who wants control? And so on.
So they can be at different locations and
Yes.
working together.
Mm-hmm.
Because I have 2 courses for in-service teachers
Mm-hmm.
in mathematics. So this would be a very good program.
Yeah, the only problem is to get them to coordinate to a certain time that they
Yeah.
can all work together.
That's true.
Maybe after school, 4 o'clock or something. Or in the weekend, whatever's convenient to them. That's always the problem, is to coordinate a time.
So tomorrow is a session for...
For analysis of data.
Okay.
So we're going to look at one of the groups, how they did over a series of 8 sessions.
Because I'm not able to participate tomorrow.
But I think Thomas is going to become the local expert. And he has the manual here, which has tutorials about how to create your own rooms and things like that.
Those students that you are talking about, what age are they?
Well, right now we have teachers.
Teachers.
So they're, some of them have been teaching for a number of years, 10 years or whatever. Others might be newer teachers. And then their students are mainly in what we call middle school. So young teenagers, maybe 14 years old, something like that. So they have not yet studied any geometry. We had students last year who, some of them had studied geometry, some of them were almost ready to graduate from high school. So they had more advanced math even, and then this was going back to geometry for them.
I think you said that you view this as a kind of constructive approach to mathematics,
Yeah.
philosophically speaking. And you compared to realism or platonism or whatever. But then you also said, I think you can wobble between talking about constructing mathematics and constructing knowledge of the mathematics.
Uh-huh.
Do you see a difference?
I guess not, really.
Because personally I could accept constructing knowledge of
Yeah.
mathematics in this way. But looking at this as constructing the mathematical objects, that for me that would be something else. I mean, you are still constrained in constructing triangles as they actually are in the sense you have no real freedom in constructing whatever you like.
Well, you can construct things that are not part of Euclidean geometry.
Yes. Yes.
So we have one. Are you familiar with taxicab geometry?
No.
So we have one lesson on that, which is a non-Euclidean version. So they are asked to think about constructing tools that would be restricted to the taxicab grid, and to explore what a triangle would be in taxicab geometry, and so on, what a circle would be. And there's another lesson in here on transformations, rigid transformations, and where they're given the idea of exploring how a kind of grammar of transformations. So if you use a certain set of different transformations, can you replace that with just one kind of transformation to do it equivalently? Things like that. And given the context of designing a sort of factory workflow simulation, what would be the most efficient set of transformations to use and things like that. And so in that sense, they're coming up with the little mathematics of that simulation system, which maybe no one has done before. So. It's not, I don't claim that it's a pure creation out of nothing. It's this combination of discovery and of discovery of constraints that are in these objects with a creation of new combinations that include those kind of constraints.
But still in a kind of context of discovery.
And there's the whole spectrum between guiding them to understand some of the concepts of traditional geometry versus other topics where they're much freer to invent their own, at least, path of discovery. Once they have some of the basic, know how to use the tools and so on.
I suppose you could also invent tools for non-Euclidean
You
geometry,
can.
like the Klein model or
You can.
or something like that.
Yeah. That's been done using GeoGebra. Yeah, you don't have to have parallel lines never meeting.
I think it's important also to emphasize that the tool that your university has developed can be used for many different branches of mathematics. I mean, we can teach calculus this way, or
Yes.
statistics, or
Yes.
whatever in GeoGebra, since GeoGebra fits in the framework of the VMT tool.
Right.
Yeah. Which is really promising. I mean, collaborative work could be done in different branches of mathematics.
Yes, I mean, once, and not just collaborative, but once the student, as an individual learner, once they've mastered GeoGebra in the context of a basic geometry class, they can use it in their future classes for trigonometry and statistics, calculus, and so on. Even on their own, even if it's not used in the course, they can use it on their own as a tool to think mathematically with. You know, especially if they really learn the full power of it to do constructions and even to do their own custom tools and so on, then it becomes a powerful tool for them in future life.